Hi, everybody. I'm Robert Douglas, and this is Deploy Friday. It's the best day of the week to deploy your code. Nothing can go wrong. Promise. I promise. Double promise that it's the time to deploy your code. Go do that. We'll wait. Come back, and we've got a great show for you. On the show today, we've got three guests who are going to talk about a form of distributed computing called the Golem Network. And we're going to find out how you can run applications on a global, anonymous, unstoppable compute resource that's put together of computers all around the world, and how that works. Amazing, right? Let me introduce my guests. With us from Berlin is María Paula Fernández. Hi, María. Nice to meet you. Thank you for joining us.
Thank you.
We've also got Mattias Nystrom from who's Swedish and is in Poland via Australia. You can ask questions about that if you're curious. It sounds very complicated.
Yeah, that's great. Thank you for inviting me. Thank you, everyone.
And Stefan Adolf, a veteran to the show, as some of you will know, who hails from Berlin as well. So welcome, everybody. So let's go around and do some more thorough introductions. And in particular, tell us what your role is with Golem Network, or in Stefan's case, why you're interested in it, and how you came to be involved. María, go ahead, start. Tell us where how you got here.
Yeah, sure. So I am María Paula. I am actually Argentinian. I'm not from Berlin. And I arrived in Berlin about 8 years ago now. And basically I came across Golem when I joined the blockchain ecosystem around 2017. I was working back then for Polkadot, which is a heterogeneous multi-chain platform. So that means an internet of blockchains. And I was very happy there, but I felt I needed a little bit more community. And then I discovered Ethereum. And my mind was blown. I wanted to work on Ethereum. I thought, okay, I want to find a couple of options that I actually like. So I lined up my favorite projects at the time. There weren't that many. It was 2009 and 17. So I lined up my favorite projects and I started applying for jobs. And I got one of them, which was Golem, actually. So I've been there since January 2018. I started as communications, and now I am one of the advisors to the board. And on my spare time, I write about art and blockchain. And I have one of the biggest hackathons. That's where I met Stefan within our community in Berlin, East Berlin.
Amazing. Wow. And all of you people out there who might watch this show regularly, you'll notice that this is technically literally the first episode that we've ever had where we're going to focus on blockchains a little bit. So brace yourselves. Mattias, how about you?
Hi, yeah, so thank you for inviting me to the show again. So I first got interested in cryptocurrencies in 2013, usually kind of a little bit similar to how some people hear about crypto, which is a platform for investing or speculation. But further than that, I kind of grew my interest in peer-to-peer technology, specifically like Golem Network. That started growing in 2016 when I discovered some talks by a very talented presenter whose name is Andreas Antonopoulos. He's quite popular in the Bitcoin space and talks a lot about Lightning Network, and has represented the Bitcoin community in various ways. And that kind of sparked my interest for not just the cryptocurrency aspect, but also the code behind it. And with that, also in particular, layer 2 solutions that can kind of speed up payments of cryptocurrencies, where you build a second layer on top of, or second peer-to-peer layer on top of the kind of global network, which would be Bitcoin or Ethereum, and then do payments that way, which really got me interested in trying to help others learn as well. So at that stage, I think it was around 2017, I joined with a friend of mine who was writing blogs to try and educate people about the technology. And from there, it just kind of grew a bit. I'd try and help people learn, try and help organize communities. And it grew into my role that I started at Gollum just over a year ago. So MP, María Paula, reached out to me and said that I've got an interesting offer for you if you would like to take it up. But the catch is that you would have to move to Poland from Australia. And at the time, I was like, yeah, that sounds great. I want to go to Europe, do some interesting cryptocurrency work. But little did I know that also the pandemic was looming. So it wasn't the best timing, but I think it's worked out for the best anyway. So from there, currently I'm working as head of community and just working on community development at Gollum, doing different reports, updating the community on what we're working on, and yeah, just different growth strategies and rewards programs as well. I think
Perfect.
that's most of it for me.
Nice. And, you know, with the pandemic, it's like choose your bedroom to stay in for a year, right? It's like Australia, Poland. It's all the same. It's all indoors,
Exactly.
right?
Exactly.
So, Stefan, how about you? Who are you? Why are you here? And what's your interest in distributed computing?
That's a pretty good question, Robert. Actually, so just to continue the whole story, I'm actually a native Berliner. I've been born in Spandau, which makes me not 100% native, but I'm pretty proud about that. I'm living in Neukölln nowadays and working for a company called Turbine Kreuzberg with the brilliant job title Developer Ambassador. And that leads me to one of the things that our agency is doing. We're actually concentrating on decentralized technologies. We're not only doing that, we're also building lots of business-to-business enterprise platform, marketplace, software solutions for our customers. But we got at least 10 people in our company working on decentralized stuff. And well, we're always looking for customers, actually, but this is a little advertisement here, but this is not our main plan now. I'm actually into the blockchain scene for more than 4 years. I attended at least 30 hackathons during the last couple of years. And I got my hands dirty with lots of this stuff. So starting with decentralized storage technologies like IPFS, doing full stack development on dApps, have written lots of Solidity code already, and I'm usually trying to join all the hackathons out there that, for example, Consensus is doing, just to gather all the knowledge, to bring the knowledge from the world and you people actually inside our company, and to carry some stuff that we are evaluating inside Turbine Kreuzberg outside to the world. This is what I'm doing now, actually.
And you do it very well, which is why you're on the show. Thank you. So, María Paula, here's the big question. What's Golem Network? What problem does it try to solve?
So at the very, very high level, Gollum is a protocol for the exchange of digital resources. And, you know, like, I'm not saying computing power because this is not the end goal of Gollum. In the future, we aim to just be, you know, like a constellation of marketplaces, because you will also have different options on which you can exchange with other users across the globe, you know, digital resources. So, you know, be it a data center or, you know, maybe in the future as well, if a phone, you will be able to rent other people's devices. And right now we have a reference implementation called Diagna, which is a P2P marketplace for idle computing power. And you can rent computing power from other people, being a developer or, you know, a requester needing, let's say, rendering an image, and you can get paid in our native currency that's called GRM, which is a currency that now, so it's the reference implementation, it's called Diagna, just so you know. And yeah, I can't remember correctly the acronym, but I'm gonna look it up for you. Yeah, thank you for writing it down there.
I believe it's yet another Gollum application.
Gollum native application.
A Gollum network application, yeah.
Yeah, we were a little bit
wait.
defeated
Yet
when we...
another Gollum network application. Okay, got it. Thank you.
Yeah. We were a little bit over it when we chose the name. Gollum has been you pay computations in the native currency GLM, which is the payment driver is built on a layer 2 framework, so you don't have any scaling problems with Ethereum, which are very widespread right now. And Gollum has been around since 2014. Actually, we presented in the first DevCon 0, Ethereum's developer conference. And from there, we crowdfunded in 2016, before it was cool to have a coin. We were there during the DAO hack. Actually, we were going to crowdfund via the DAO, the old DAO, not any kind of DAO, the one that got hacked. And come 2018, we launched our first mainnet. It wasn't good enough to go to market, but then we took some time to learn more things and to learn about our users, and we decided to start sort of from scratch with a new code base, and that's where Yagna came about. And we launched Yagna to the Ethereum mainnet, so we launched twice to mainnet. Again in April or March this year.
Okay. So that's very interesting, because as I was reading the website and the examples and the documentation, this broader concept of a marketplace of any type of digital resource didn't strongly come through to me. So that broadens my understanding a little bit from what I was able to gather just from the marketing materials on the website. Why do we need that type of marketplace right now? So that's what it is, and that's what it does. But I haven't yet heard why this is important to the world. What business driver will push this forward?
Well, first and foremost, Gollum provides a decentralized, censorship-resistant platform that's also anonymous for developers, requesters, and providers alike. And I don't know if you were around during November, December, the past year, a lot of platforms got deplatformed. And, like just this week, we actually got a video taken down from YouTube for no particular reason, because it was a live coding workshop. So this is why we need decentralized and censorship-resistant alternatives to the platforms that we have. Anything that you build, almost anything that you build, as a developer requires a degree of computing power. Say you have like a really broken old MacBook that, is constantly lagging, then, you can't really run your applications, and you need more computing power. You also need storage. So this is where Gollum comes in. We provide the infrastructure that you need as an application developer, or if you're running very heavy like computer programs, for example, rendering for MRIs, brain scans, which are really compute intensive, then, you need something else. Of course, you can now go to AWS or Azure, but that doesn't solve any problem, because that's Google and that's Microsoft and that's Amazon. And in the end, if what you're running maybe doesn't fit, their sort of like really vague terms and conditions, you risk being taken down. And what happens there? You lose your work. And I think that's a really big deal. I wouldn't like to lose or get deplatforming is a really big deal, because it has happened to all of us in a small degree, maybe some developers in larger degrees. I got taken down a video from Instagram. For me, that I use Instagram just when I'm bored, that doesn't, it's not a big deal. But what happens if my livelihood actually depends on that video? Or what happens if you're actually building an application and you can't store everything at home and you can't compute everything at home? Then, that's your life. That's the life of the users of the applications as well. So, I think the problem we're solving is actually, the problem with monopolies.
Okay, so if I summarize, in your opinion, the main driver for this type of technology is to not be subjugated to the decisions of corporations who don't have your interest in their mind. Okay.
Right.
I'll buy that.
I actually had wanted to add this. Of course, there's good applications and there's bad applications that are searching for censorship-resistant infrastructure. This is a really big challenge. We don't take it. Like, I have political views too. I have a soul. I care about the world. I don't like people that are going into hate speech platforms or so on or so forth. But in the end, I need to look past all of that and understand that for one bad guy, there's probably 10 good guys that are wanting this infrastructure because it's reliable, and that's who we're building for.
Okay, great. So let's move a little bit into how it works. So maybe, Mattias, this is a question for you. But from what I've read, I understand that there are requesters and providers, and then there's stuff in the middle. Can you make that a little less fuzzy for me? Who are the requesters? Who are the providers? And what's the stuff in the middle?
Yeah, so pretty much anyone can be a requester or provider. So it's permissionless for anyone to join, and they can either decide whether they need to buy some computational resources to be able to compute something, render an image like MP said, or if they want to be the person who's renting out the computational resources. So if they have some hardware that's standing there, they're not really doing anything with it, and they would like to just make a little bit of extra money from this, or earn some tokens from this hardware that's sitting there, then they can join this this network, and it kind of creates the marketplace between the whole network, where it's a marketplace of providers or the systems that are trying to give their resources, and they can set their prices for their resources that they would like to offer. And then you have the requesters who want these resources. They'll look through what the market has to offer, obviously, kind of similar to going to a store and you pick between different kind of produce that you want to buy. You decide whether it's worth it or if it's not, and if it also suits your requirements. So a requester can say that I need these specific requirements. It needs to have this amount of disk storage, or I'm not going to even consider that as a person that I'll engage in a agreement with. And once they kind of once you decide with a set of providers that you want to do some computation with, you'll send out your task, is what we call it. You'll send out your task to these providers. It can be multiple providers at the same time. So you might split up your task to make it less load on each provider, or maybe you just send it all to the same provider and they'll compute. And then when they finish, they'll send the results back to you. So it could be something like password cracking, where you might have a phone and you've forgotten your password, but you're like, oh, I remember it has these 2 words, but I can't remember the last part. So you might send it out to the network, and then the network solves it for you because you don't have the resources to do it yourself. Which kind of goes back to a little bit what MP was saying, where sometimes you just don't have enough resources, so it just benefits you rather than buying the resources yourself or going to Azure, going to Amazon. You can just do it quickly on Gollum. And what's good about Gollum as well is that you don't need an account. So you don't need to sign up. You don't need to ask us to be, or us as the people building the network. You don't need permission from us to join the network, either as a requester or as a provider. You can just jump on, be like, this is the workload that I want to do, or this is the computation that I want to provide. And the Yagna daemon will kind of sort out everything in between. So it helps you sort out your agreements with providers on the network. So there's not actually that much that you have to think about unless you really want to. So if you want to dive into the code and make more complicated agreements, you can do that. So if you get a result as a requester from a provider and you don't kind of like that result, or it was taking too long, or there was some issue there, then you could write into your code, for example, that you're going to blacklist this provider because you didn't like the kind of experience you have with them. So you could kind of think of it as the provider being a service provider, so they're providing a service, and the requester is the customer, so they kind of decide who they want to take their business to.
Okay.
Yeah, I think
Thank you.
those
Now,
are the main parts.
when I was looking through the examples that I could find on the website in the relatively small amount of time that I had to investigate you prior to the show, the example that you use actually takes basically a Docker container, and it compresses it into something very minimal so that it can be transferred over the network really easily. And so it doesn't take forever to transfer. And it runs that on the provider's machines. So the theory here is that as a requester, I have a workload that I can express into a Docker container. In this case, it was a Blender application rendering some images, which can be, very computationally intensive. And usually for big jobs, you rent GPU instances on some cloud at a very high cost, or you build your own rig because, you need those GPUs and you don't have one in a MacBook, like you said. So I send this Docker file-like thing over to some provider who has provided disk space and CPU, maybe measured in cores or physical CPUs, measured in gigabytes, whatever, and at an agreed price. And they compute this for me and send back the result. And I could have inputs into the computation during that time, from what I understood. How's my understanding on that? And can you flesh that out anymore?
Yeah, that's pretty much the correct understanding. So when you first get to our developer handbook, we call it, so at handbook.golem.network, it will kind of guide the developer through that process if they want to be a requester. So once you get to the handbook, it will ask you at the top, it will be, do you want to be a provider? Or it just says providers, and then it says requesters. The individual will decide which path they're taking, and if they're a requester, they will go and take what we kind of call our flash tutorial, or it's essentially a quick start guide, where it guides through the user of first installing Gollum, and then running the daemon, and then doing what you described, where you run your first task, which is this Blender example that we call it. So we have a pretty basic example that will just start the person sending their first task out, where they pay on the Ethereum test network, so it's not real tokens. And on that test network, it's essentially a free network that we run a few computers on. It doesn't have anywhere near the amount of kind of computational resources that are available on the real network, where the GLM token is used. But it's more just to get them started, help them understand kind of what's happening with their payments and how their task is created. And then after that section, where it essentially shows them all the steps that they need to do to run this first task, it will take them on to a section that describes kind of how everything kind of occurred, and how to get them started on writing their own applications and creating their own tasks to run on the network. And we also provide a little bit extra on top of that, because obviously that Blender example uses some test tokens, but if some developers want to get started on trying out Gollum on the main network, which is where the real fun is, where we have over 500, when I last checked, over 500 different nodes or computers that are providing resources to the network. We provide a little bit for requesters in the form of a faucet that will give out a few GLM tokens, so they can actually run some tasks and try out Gollum in the real world.
So I think you need to explain for me and the audience the idea of a faucet. I've seen that term before, but I would not dare try to describe it myself. Maybe, Stefan, that's a question that I'm sure you could probably answer.
I can definitely answer that. And just the main concept of a faucet is, if you want to join any kind of network and you don't want to spend real money, then there are some let's call them happy gods, that will give you some money for free. But since everybody would just hit the button 10,000 times, those faucets usually are a little bit restricted. So maybe you have to tweet about a project, and then the faucet checks the tweet. This is a social activated faucet, actually. And then they will send you some test tokens that you can use to consume any service that's behind those tokens. But in the case of Golem, it's really important because, I mean, you would not spend 100 euros in gas costs on the Ethereum mainnet just to get started and figure out that you can print hello world. This is why you definitely need some testnet utilization. And this is what these people are doing. They are giving you everything to get started, to figure out how this feels, maybe a little bit about the latency. And then you can just play around with the test nodes for free, just asking the faucet, can you give me some money? Yes, here you are. And usually those faucets are just online. Some of them go down from time to time. Today, I think the girly faucet was down. This can happen. Then you can just write somebody and say, please, I need more money. And usually they're just filling up the faucets, and then you get more money.
What a world. I think I could have used faucets when I was, 15, 16, 17, 18 back in the day. It would have made buying, candy at the dime store a little bit easier. Okay, so I think I've got a basic idea of how things are going. What's the ideal type of workload? I heard things like, brain scan imaging. So is it all like really GPU image computation type stuff? What do you see people actually doing with the network now?
There's no really, an ideal type of workload. We're building the protocol, and we want people to create their own workload demands. So basically, right now you have people playing chess against the Gollum because they can, and someone built a chess app. And we have people that have done some kind of like federate machine learning inspired model for Gollum. So there's that as well. We have the Blender example, that Blender is an open source renderer. What else do we have there? We have developer tooling. So we just had a test fuzzing framework also built on the platform. So yeah, we're just built, and of course, right now our pride and joy is actually Live at Gollum. Live is a project that we built for a scientific chemistry computation institute that's called ICHO. So ICHO. In Poland. It's a really well-renowned research institute that specializes on organic chemistry, and most specifically on scientific compute as well. So we build for them an application. It's an algorithm that runs on top of Gollum, and they're able to, the first iteration was able to perform different chemical reactions, and then simulations, and then we would send the results to ICHO, and they're able to do their research, their findings. And right now they are exploring for components which would lead to finding reactions and components that are linked to the origins of life, like life. And this is built by our team in collaboration with ICHO. We are subsidizing the computations in GLM as well, because it's very intensive, and that's why we request the computations from the providers, and then they give us the computation. But of course, it's our network, but we still have to pay them. So yeah, as you might be able to see, we have a lot of use cases, and every week there's more, because we're doing hackathons as well. So that's a huge opportunity to find new use cases.
And is it also true that you
I
Go
would
ahead, Stefan.
like to ask the following question. I mean, these are like humongous computation resources, right? That you need to explore this kind of stuff.
Yeah.
If I would just like to run, let's say, a Lambda function, like one function call, please compute something and give me some kind of result. Is this also possible, or is it actually feasible, or economically feasible, actually?
Of course, not only it's actually quite cheap, but it's very, very fast. I don't have the specifics for Lambda. We used to have a use case, G Lambda, in the past implementation. In this one, I'm not sure, Matthias.
I think we had the community created resource so we have a community member that goes by the name of Doc, who early on contributed some different applications, and one of them, what was its name? It was an application just designed to do simple, well, not simple, but different maths applications. I can't remember too many details off the top of my head, but we do have a resource where we've collected kind of all the applications that people have made in the past, and it's just what's called an awesome list. So I don't know if you, or probably people in the audience, might have heard of awesome lists before, where it's just a list of resources that links to external resources. And so we have a whole kind of page on GitHub where people can go called Awesome Golem, and they can look through the previously created applications, and all of those on that list have open licenses, so you can run those yourself and use those applications to run those kind of tasks, and kind of skip a step of having to build everything yourself. So that kind of is where on Gollum you can separate a little bit, so you can have a requester, but that requester doesn't necessarily have to be a developer, so they don't have to be the person who created the application. They can find someone else's application and run it quite quickly with only needing some command line knowledge. So they can run this on the network, but they didn't have to have created it themselves, which is a cool part about Gollum. So you don't necessarily have to be a developer.
Yeah,
That's
and
good,
long
because
story
it sounded
short,
scary otherwise.
back to Lambda, actually, I'm not sure of the cost, because, that depends. But, I think it will be, at least, it will be cheaper than, running it on Google Cloud or something. Of course, if you have Google Cloud credits, then you're cool. But that's not always the case. And it's definitely faster as well. So I think we were at 12 times faster back then. Now I'm really not sure.
I mean, it's not only about the speed; it's also about the latency, right? If you want to do serverless computations, like little things that run on your backend, you always have some latency. And I guess this is not exactly what Golem is made for, because you always have to deal something. And this leads me actually to the real question: is Golem supposed to run some, let's say, asynchronous processes for a long time? Like, is there something that can be up, and then you can that you can request, and that maybe is going down if it doesn't get any requests? Or is it just like it will execute lots of computations at once,
like a web server?
Yeah.
Right. So right now, because we just launched the second mainnet, the network capabilities are a little bit limited. We are looking to go to a place where you can actually pick a resource that it's able to always run, or you can find a constellation that's actually more specific, because basically your tasks are split in subtasks, so in very tiny tasks, and these tasks run in different resources. You could potentially pick big data centers, and then you would have the tranquility that there will be no disruptions as well. But, and of course, you can find the different set of data centers or GPUs distributed across the world to ensure that your applications will be running.
So that brings me back to a question that I had when Mattias was describing that process of picking your providers. So as a requester, I've got my task. Once I've got that, like I'm ready prepared with my task that needs to be executed, can you describe to me the actual workflow of finding the providers? I had imagined naively that might be transparent and completely automated and marketplace driven, and that the actual network itself would choose the provider for me and negotiate the payment. Is that not the case?
So it depends a little bit. So there is quite a lot of flexibility in how you create your applications. So minimally, you do need to define the minimum resources you need, but you don't necessarily need to tell the network to get the best price that you can. Obviously, I think in most scenarios you will automatically do that, but some negotiations are a bit more flexible than that. So it's up to the developer a bit how they interact with the network. So it's something that they need to be a bit mindful of. And we're also going to update a bit with the documentation that we have different kind of market strategies. So it's currently on a develop branch, but I think it will be merged to the master branch of the documentation, where it kind of goes into that topic a bit and helps the developer decide on how they would like to negotiate with the network in a more complicated way.
How do you do it now? How does it work now?
So at the moment, you'll send a list of offers, or you'll grab a list of the different offers and get a list of the providers on the network. And you'll select one of the providers that suit your requirements. So for the most part, for example, with the Blender example, it would just be random. So we'll take a random person that suits your requirements.
So there's no way to get around that step to just like not care? Like there's no market price for the resource? Is it true that somebody could charge me 1 million GLMs for running one Blender, whereas somebody might charge me 0.00001 GLMs? So like they're a huge price disparate?
Yeah, so I think for the Blender example, thinking off the top of my head, I think it sets it at 1 GLM as an absolute maximum that you will spend on, because it sends out 6 tasks at once. So 1 GLM would be 1 divided by 6. That's the maximum you spend on your first task. I'm stretching my memory here a bit, but you can adjust a little bit, and you can kind of play with how many total workers you want to split the task into, the maximum allocation, and also the there's a few different parameters when you first look into the code in the example that you go through in the second kind of step of starting. So you first start out and run your first task on the network, then you go to the bottom, there's a new tab, and it will kind of describe what you've just gone through as a requester, where it goes into what the different sections mean and how you've just interacted with the network.
Okay, and in your example just now, you mentioned go to the bottom and there's a tab. Are you in a browser window at this point? I imagined that you would be on the command line.
No, sorry. So I'm talking about in the handbook. In the handbook that we have.
Okay.
So when you're in the requester,
Okay.
Sorry, I didn't explain that properly. I was just imagining it in my mind. So when you're in the handbook, when you first completed your task and you've sent out this test task on the test network where you got free test tokens for, so they don't have any value. Once you finish that, our handbook guides you to the next section, which explains to you everything that you've just kind of told the network to do. So it shows you how to interact with the network using our either our Python API or the JavaScript API that we have developed to make it easier, so you don't necessarily need like any blockchain knowledge to interact with the Golem network, for example.
Okay, I'm still stuck on a point. I don't understand how I choose my provider. Do I like say, hey, Golem network, I've got this task. It's gonna compute an image. It's got 6 subtasks. I've got my GLMs all queued up. I'm ready to spend. Give me the providers that could do this task, and I get a list of 500, and I go through them. And how are they identified? And I thought it was anonymous. I just don't understand that step yet.
It's not entirely anonymous because the provider will select a name that they want for their node, but that name can be anything. So they still publish the different resources they have and their name to the network, and that's how you can kind of blacklist the provider as well and say that I don't want to interact with a provider that has this name because either they tried to act maliciously in some way or you detected just something strange. But once you have a list of the requirements, how it currently works, and it'll be easier to make more complicated agreements in the future. But how it currently works is that it will just select within that minimum range that you have. So as long as you're not spending more than what you've specified for your task or what you've specified in your task, then it will select a random provider in the task.
Okay, so I don't go and see Bob's laptop and choose that, versus like my pole barn full of servers in Iowa, or choose that. I put a range, and the market making is instantaneous, and the system does it for me, and yes. I don't go and choose a provider.
No, yeah. So it will choose it for you. So after you've sent out the task, it will do it within the requirements that you've set, that you've told. After you've read through the documentation and you're like, okay, I know how to set this parameter and this is what I want to do with my task, it'll select providers or multiple providers. If you say that you want to split up the task, it will kind of do that communication for you and do the negotiation on your behalf.
And then if I were to like think through the stack, like the trace, like the network hops that go after that, what kind of information could I find out where these people are, what IP address they're at? Like I've got a provider who's at like, some IP address in Russia. Like what information do I get back as a requester that could possibly tell me anything about the provider? Is there anything like that?
So currently how it works now is that the marketplace is a little bit centralized. So a lot of the communication kind of hops between a more centralized server, but in the future you would theoretically be able to see the IP addresses of who you're interacting with on the network. So, but as it's currently implemented, no. So another
and on the other flip side, sorry to interrupt. On the flip side, though, as a provider, let's say I've put my laptop out there. Okay, so all of a sudden my laptop's a Gollum node, and I've got this software running there. What's to stop me from like introspecting the memory and finding stuff out? What's the layer of protection that keeps the workload running on my computer absolutely anonymous?
So that part wouldn't be anonymous without something like SGX, which is just enclaves. So currently you would be able to snoop in a way as a provider. You will be able to see what is being computed on your computer for sure.
Okay, that sounds kind of dangerous and very limiting to the kind of computing tasks that you'd potentially be able to run. Do you see that as a business threat to the network?
Yeah, I think it is quite limiting to requesters and why they would decide to join the network. So there is quite a lot of incentives to create something like or integrate something like SGX on the network, where you can have a lot more privacy as a requester. And we've been working on getting SGX integrated and have made some internal proof of concepts on that front, but we don't have anything public. But as kind of the network grows, I think we'll be able to do that for requesters. It makes a lot more sense to send out tasks if I can have it be private. Naturally, a lot of people don't want their information snooped on or what tasks they're running on the network snooped on. So yeah.
Stefan, can you explain me what SGX is? I don't know.
No, actually, SGX is well, this is a secure computing enclave on CPUs, as far as I know. Matthias, just prove me wrong if I'm wrong with that. But I was just thinking about zero-knowledge proofs and homomorphic encryption, actually, because the only thing you really need in a decentralized way that you need to solve is give me a CPU so I can run stuff on it, okay? This is something I would be always able to pay for. But what's really hard to solve is in a decentralized world is security, actually, because you don't know anything about the people you are communicating with. And if you want to keep certain things secret, you need modern cryptography. And what you usually do is actually you encrypt the machine that you want to run. You encrypt the inputs that you provide the machine. You tell some CPU, please run that for me. Here's some encrypted input. It will never be able to read that, and it will give you an encrypted output, and you can read the encrypted output. This is actually the masterclass, how decentralized computing, in my perspective, is working. But we are not there yet. What Golem is really solving, from my point of view, is they can sell computing power, which is really important. This is one of the biggest milestones, actually, like providing computing power.
To be clear, in the subject of trusted execution environments, so enclaves, we have been working with them since 2017 right now. We have several prototypes. We even spun out of a project called Project Graphene together with Intel and 2 universities from the US. And basically, Graphene is more of a library operating system that already features data integrity and confidentiality. In the topic SGX, we are as well advanced, but right now, yeah, and if you Google SGX, you will see like it's sort of like a normal fixture to see SGX hacks all the time. SGX is it's not a very new technology, but it's also not fully polished just due to the complexity of it. SGX enclaves run on Intel processors, and so if you actually have if you actually nail down SGX, because Intel is so widespread, you would get to a very good level of data integrity and confidentiality already in the network. So it's about reducing the surface of of attack, and it's less about finding a silver bullet. In the future, of course, we need to extend the offer and keep on doing more prototypes for other trusted execution environments, not only SGX. But it's a very hard problem, especially when SGX is still like a developing technology that's prone to attacks as anything else in the world.
Cool, thank you. So let's talk about the payment aspect of this. So as I've understood, the actual computing and distributed network and all of that right now actually doesn't touch blockchain at all, and that the blockchain element is there strictly for microtransactions that can be automated. Is that true?
Yeah, that's pretty much correct. So yeah, we use, like we were saying before, we use Ethereum for payments. But one of the challenges that we ran into very early on, and something that we were quite aware of almost from the start, was that this could become quite expensive for the purposes of doing micropayments. Especially recently, gas costs on Ethereum have skyrocketed, which don't really suit Golem transactions, because usually they're in the range of maybe $1 to 1/100th of a dollar, or it can be even less, and hopefully we can run even smaller. So we need something that can be in the 1,000th of kind of the price range that we're looking on Ethereum. And to do that, it kind of goes back to what I was mentioning that I was quite interested in when I did my introduction, is doing a second layer of payments on top of a layer. So you can have Bitcoin or you can have Ethereum. And on Ethereum, what we've integrated as a payment driver, as we call it, is CK Sync, which is zero knowledge rollups, which is layer 2 payments, essentially. So you can get a much cheaper layer while still relying on the security of Ethereum when you come off that layer. So in that way, we've been able to do GLM payments for token transfers between participants on CK Sync, as it's called, and that's currently around 1,000th of the fees that we see on Ethereum. So if you transfer a token on Ethereum, you might expect over $10, I think, in the recent days. So fees $20, I think. I'm not sure. I didn't try and transfer because I'm just like, that's too much for me. I'm not going to try and do anything. But that's not very useful when you have a platform where people should be able to transfer all the time. You shouldn't be looking at the transfer fees and being like, I'm not going to interact with the network because gas costs are too high right now. So
interesting. So what I just heard is really fascinating, and you can check and see if my understanding of what you said is correct. If I think about your goal, let's say you become the Airbnb of unused computing resource, okay? Really, the sharing network, and you extend it to mobile, and everybody who's got like one of these things can all of a sudden rent out their incredibly powerful little mobile chips, plus their laptop and any other computing device they've got. Let's say it's a perfect world, and you suck up all of the available computing power that's not being used for anything else right now and make it one big global provider. Let's just say, theoretically, okay? That would be great because people who want to do amazing computing things, like Stefan, who would like just bring down the entire world's computer network if he could, will go out and start doing things like those brain scans that they couldn't do, but they've always wanted to, right? Those brain imaging scans or whatever else, like Fibonacci numbers to the, to the end of the universe. But the thing holding you back is not the actual price of computing power, which is basically infinite right now because there's so much unused computing power, right? Like my phone's sitting here the whole time going, I'm really bored about 10 trillion times a second, right? It's like, I hate being a computer. It's so boring. Give me something to do. Can't you just play a game, please? No, he's got to sit there and wait for me. So there's all this unused computing problem. So there's like the supply and demand is way out of balance, but the transaction cost is too high. Like you're going to have a hard time getting like Lambda costs like right now because like they're charging like they're like 4 or 5 or 6 or 7 or 8 zeros before I get to the 1 in the per transaction cost that Lambda gives me. It's like almost no money ever to use Lambda unless you get really big. So is that right? Is like the thing that's like driving the cost of your computing power up high right now really the transaction cost?
Yeah, exactly. So that is a very big challenge, and that's what we realized early on, and our platform to start off with wasn't modular enough for us to be able to tackle that challenge and a few other challenges properly. So now with how we've integrated CK Sync, it's kind of what I said, 1,000 times cheaper, but a bit like what you're saying, we're seeing like a lot of zeros, more than 1,000th for something like AWS Lambda. Sometimes we're seeing, I'm not sure, it might be 10 zeros or something before the actual cost. So we want to see if we can integrate payment drivers that are even cheaper or maybe even layer 2 solutions on top of layer 2 solutions. So you can potentially have a layer 2 solution that acts a bit like Ethereum and then put something like state channels on top of that or payment channels where you can start to look into having transaction costs that are not like 1,000th of a cent, but more like a billionth or even higher than that. So we do still need to improve a bit on what we've currently got, but obviously 1,000th is a lot better than running tokens directly or running token transfers directly on Ethereum, that's for sure.
Now before we close, let's talk about something really fun. So I looked at the history of the company a little bit, and you mentioned this also, Maria Paula, that the GLM token was created by the Golem Network some years ago already, and it says that the ICO, the initial coin offering, sold out in 29 minutes.
Mm-hmm.
Creating a market capitalization currently of $322 million. Do I understand that correctly?
So the ICO doesn't create the market capitalization, but all of the rest is true. So
where does the market capitalization come from? It comes on the open market, right?
It comes from the price of the token. And the price of the token is currently around 36 cents. The last time I checked, but don't quote me on this because the market is crazy these days. So that creates the market cap. Because the token, of course, since it's been so long, it's fully in circulation right now. So, like there's like crypto people out there just deciding what's the price of our token, and that dictates the market cap. What you are describing?
How are they deciding? I know I don't want to get into a whole market making
Supply
conversation.
Supply
but
and demand.
Is it really supply of people who are requesters requesting compute resource on your network?
No. Tech is never linked to token price. Forget about it. That would be an ideal world, and I would love that to happen. And in the future, I hope it happens that way, that the usefulness of the network determines our market cap. But right now, it's mostly, a bunch of traders just determining prices across.
So that leads me to a question. That leads me to a really important question, though. If I'm a requester and I'm going to be paying in GLMs, okay, and I'm like looking forward to my next month's brain scan schedule, and I'm going to have to scan Stefan's brain, so I'm going to have to really beef up on the GLMs to get that one done. Right? Going to find some scary stuff in there, right? So I need a lot of GLMs. I go buy my GLMs. They're 30 cents now. What happens if the price of GLM goes to $60,000, like Bitcoin? What does that do to my cost of requesting compute?
Not much, because it rebalances. The price of compute is contingent to the market. The price of computing GLM is contingent to the market conditions. Of course, if let's say in March you were requesting computing power and you paid 5 GLM, and now the token has gone up, then if the provider held the GLM, then they have a little bit more money than they had when the task was done. But it's not, it's not an expense for you, because you already got the task done and you already made the payments. It's all about them not selling.
But is it true that I would have to have a cryptocurrency wallet and use some fiat currency or some other means to get cryptocurrency into that wallet before I could purchase the GLM tokens to begin with?
You actually can go to our faucet and ask us nicely for the time being.
But the faucet's not going to feed the rest of the world. We're talking like when you hit mainstream, right?
Yeah.
Like the future of this is I would have to turn fiat currency into F and then GLM, or straight into GLM, and then I've got this in the wallet and I'm saving this, and then I'm like subject to the price fluctuations, right?
Right. Yeah. And I don't make the rules here. Hopefully, so you should be able to port your GLM to Ethereum's layer 2 and then just use GLM for relatively low cost, maybe in the future, hopefully. Right now, because everything is so volatile, everyone has, including gas fees on Ethereum, so transaction fees, you have to plan accordingly. But, sorry, but with great power comes great responsibility, Robert. So, you want the computing power of the world, then, you get ready to spend your bucks. And then in the future, we will get it better.
I like that. That's a great positive message. We're at the top of the hour. It was a really great conversation. I think I understand a lot better what the Golem Network does. And I hope that the people who are watching and who will watch in the future also do as well. Thank you, María, Paula, Mattias, Stefan, for this conversation. And come back next week for more of this good stuff. It's Deploy Friday. If you didn't do it at the beginning of the hour, I really demand now that you do deploy your code, because it is Friday. It's the best day to deploy your code. Thank you, and see you next week.
See you, good people.
Bye, everyone.